Hi everyone, this is lesson 3 and we're going to be looking at rates of change and evaluating functions using a graph. So just to warm us up a little, practice on determining whether a function is even, odd, or neither. You could put this into your calculator and look at the graph, or you could do it algebraically. That's how I'm going to do it. I'm going to put a negative x into the function and I'm going to see if the signs change or not. When we have a negative raised to an odd power, it's going to remain negative. All right, so let's see what we have. We had a positive, and now we have a negative. We had a negative, and now we have a positive. But these two guys stayed the same, so that kind of blows it up for us. Since all the signs did not change, this is a neither. All of the signs change, it's odd. If none of the signs change, it's even. And if you just have some of them changing, it's neither. All right, so let's get into using the calculator to evaluate a function. So we want to find a function value, and we're going to do it using the graph. So the steps for this would be we'd graph the function, make sure our window shows the specified value of x. We'd go to second trace for the calculate menu, and we press enter to get the value option. So I'm going to show you how to do this. So first, let's enter the function into our calculator. Okay, once we have it in our calculator, we're going to look at the graph. And we're going to be evaluating this function for the values of -2 and 3. And we want to make sure that the x value of -2 and the x value of 3 can be seen in our window, and it can. If there's any issue with that, you would go to the window button and you would change it, but we're good. So we're going to go to second trace, which will give us calculate, and we're going to pick number 1 for value. Right? If we put in the value of -2, and make sure you use the negative one, not the subtraction button, or you'll get an error. So we'll put -2 and we'll hit enter, and we get 4.25. And now we're going to do it for the value of x equals 3. And we get 4.5. So very simple, easy to do. All right. Another thing we can do, finding a missing variable using the graph. So using that same function that we entered into our calculator, we're being asked to solve for the value or values that satisfy f of x equals 4. So in other words, where is y 4? So we're going to look at the table of values, and we're going to find any x values that have a y equal to 4. So we're going to go to our table, which would be second graph. You see we have a 4 at x equals -3, and we have a 4 at x equals 5. So our answers here are -3 and 5. That was easy. Right, you may want to pause here, and when you come back, check your answers. I'm going to go to second calc, enter the value. The first value we're looking for is -4. That gives us 7. And the second value we're looking for is 2. And that also gives us 7. Solve for the value or values that satisfy where y is equal to 1. So again, for that, we're going to go to our table of values, and we're going to look and see, where is y 1? So for this one, y is 1 at -2, and y is 1 at 0. On this next page, we're going to be looking at average rates of change. And just as a reminder, I put here the average rate of change of a linear function. And this was Algebra 1, and I'm sure you saw it again in geometry. Recall that the slope, the average rate of change over a line, is given by this formula, right? The change in y over the change in x, or the rise over the run. It just gives you a little example of what we meant by the rate of change. Now, the rate of change is constant in a linear function, right? But when we look at a nonlinear function, the rate of change is not constant. So let's just make a note here when we're looking at the linear function, that this function in this case is increasing at a constant rate. Anywhere you look on this line, we're going to get the same slope. Now, if you look at a nonlinear function, the slope changes. So, we have positive slope here and maybe a little smaller value for the slope here and very steep slope here. So we want the average of that when we're talking about nonlinear. So our average rate of change for a nonlinear function has this formula. Right? When we're looking at the function over an interval from a to b, we can find the average rate of change using this formula. So let's look at some examples so you know what I'm talking about. Find the average rate of change over the interval from a to b. In this case, it's from 1 to 3, for the function represented by the table below. So I always like to write the formula, especially when it's new. And then let's start filling it in. So we need f of 3 minus f of 1 over 3 minus 1. Well, f of 3, if I put 3 into the function, I get 16. If I put 1 into the function, I get 4. 3 minus 1 is 2. 16 minus 4 is 12. 12 divided by 2 is 6. Great. Find the average rate of change over the interval 1 to 4. Again, the first value is always a, the second value is always b. We'll write the formula. This time we have to look at the graph to find f of b and f of a. So we want f of 4 minus f of 1 over 4 minus 1. F of 4, so if I put the value of x is 4 into this graph, I get 2. F of 1, I get an output value of 1. So we get 1/3. All right, not so bad. Find the average rate of change when we have a ball thrown in the air, has a height of the given function, and it's giving you, this function is giving you the number of feet after the input value of t in seconds. So what are the units of measurement for the rate of change for this particular question? So the units of measurement here are feet per second. How many feet per second is the ball moving? And we need to know that average rate of change. So we're looking at the interval from 0 to 2. So we're going to be doing our same formula. In this case, we're going to say h. H of b minus h of a over b minus a. So we've got h of 2 minus h of 0 over 2 minus 0. So what we need to do is we would put 2 into this function. So for example, we would say, what's h of 2? Well, we'd substitute 2 everywhere where we see t. And we do the math on that. So then we end up with 36 over 2, which gives us 18. feet per second. All right, now we're going to compare rates of change between different parent functions. So comparing functions helps us gain a better understanding of them. Let's take a look at, we have a linear, we have a quadratic, and an exponential. And just to make this graph a little easier to read, and you may want to do this on your paper, I'm going to highlight the linear in yellow. Okay, so that's going to be my h of x graph. Then the next graph I have is the quadratic graph. I'll do that in blue. And that one is g of x. They all start to kind of look like the same graph. And then we have the exponential, which I'll do in green. So we've got our exponential graph. Boom. Okay. So we're going to answer some questions about these just to compare them. We want to know, is h of 1 greater than g of 1? Well, if we go to the table and we look at h of 1, if we put 1 into the h function, what do we get? We get 3. Is 3 greater than g of 1? Well, if we put 1 into the g function, we get 2.25. So this guy is true. If we have f of 1, now in this case, f of 1 is 2. Is that greater than g of 1, which is 2.25? That would be false. G of x is the only function that decreases. Well, let's look at g of x. Now, g of x is the guy I have colored in blue. All right, g of x is the only function that decreases. Well, there is a decreasing part of this graph right here. The linear function is always increasing, and the exponential function is always increasing. So I believe that part C is true. H of x only decreases, it does not increase. Okay, h of x, where's h of x? H of x is the linear function, and that function is increasing, right, over the whole graph. So this one would be false. It only increases. F of x only increases, it does not decrease. All right, so f of x is in green. F of x is increasing the entire time, so this one would be true. Right, we're going to do a little practice. I would say pause the video, try the practice, and then play it again when you're ready. Compare the two functions, determine which statements are true or false. The values of f of x exceed the values of g of x over the interval 0 to 4. Right, so it looks like the values in the f of x column are all greater than the values of g in the g of x column. So this first guy is true. Right, f of 1 is 2. G of 0 is negative 10. 2 is greater than negative 10, so that's true. F of 3 is 6. G of 4 is 6. 6 is equal to 6, that's true. F of 4 is 8. G of 0 is negative 10. 8 is not less than negative 10, so that's false. All right, last one here. Complete each sentence below to determine how the growth rate of f of x compares with g of x. Now, you may not know, unless I gave you a word bank, what possibly these words could be, so don't panic. I won't do something like this to you on a quiz or a test without a word bank. The graph of f of x increases at what rate because it's linear? Well, when we have a linear function, it will either increase or decrease at a constant rate. The graph of g of x increases at an increasing rate because it's quadratic on this graph anyway. The only part we're seeing of this quadratic function is increasing. It's not constant, but it is continually increasing. The graphs can be shown to intersect at what point? Well, they're intersecting right here, and that's the point 615. The value of g of x is greater than the value of f of x. So g of x only starts getting greater right here. So after the value of x equals 6. So where x is greater than 6. All right, that's everything for this lesson. Thanks for watching. Have a great day.